Did you know that some of the universe's fundamental laws work just as well forwards as they do backwards in time? It's a strange and honestly pretty unsettling thought. Imagine shattering a glass. We only ever see the pieces fly apart, never the shards leaping from the floor to reassemble themselves into a perfect cup. Yet at the subatomic level, the rulebook of physics doesn't explicitly forbid it. This symmetry, this indifference to the direction of time's arrow, hints at a profound and largely unsolved mystery about the cosmos. For most of the last century, one story has dominated our understanding of cosmic origins. We call it the Big Bang. One of the most famous pieces of evidence was discovered almost by accident in 1965 by Arno Penzias and Robert Wilson. It was the cosmic microwave background, the leftover heat from the universe's fiery birth. What if the Big Bang wasn't a beginning, but a bounce? Imagine a perfectly bouncing ball, dropped from a great height. In this model, our universe is just one iteration in an endless series of cosmic cycles. This concept has been championed by physicists like Paul Steinhardt of Princeton University. One potential source of evidence is gravitational waves. Missions designed to detect these ancient gravitational waves, like the European Space Agency's planned LISA mission, could provide a definitive test. Another fascinating piece of potential evidence comes from the late Sir Roger Penrose, a Nobel laureate. He predicted that the final moments of a previous eon would leave faint circular patterns, Hawking points, in the CMB of the next. Some physicists propose a radical idea, that the Big Bang was not the beginning of time, but rather a central point from which two arrows of time shot out in opposite directions. From this central moment, the universe expands and becomes more disordered in two opposite temporal directions. On the other side of our Big Bang, there could be another universe, identical in its laws of physics but with its arrow of time running opposite to ours. This theory suggests that the three-dimensional reality we experience might actually be an illusion, a projection of information stored on a distant two-dimensional surface. According to their calculations, the maximum amount of information that can be contained within a region of space isn't proportional to its volume but to its surface area. If the universe really is a hologram, the Big Bang itself wasn't the explosion of a three-dimensional point, but actually the moment our holographic projection began. The idea of a timeless or cyclical universe, it's honestly not a new one. In ancient Hindu cosmology, there's this concept of a yuga cycle that describes time as a great wheel. This eternal process of creation, preservation, and dissolution is actually remarkably similar in spirit to the modern cyclic universe theory. Similarly, the Stoic philosophers of ancient Greece and Rome had this idea called ekpyrosis, a periodic conflagration that would consume the universe. They believed in an eternal recurrence, where every event was fated to happen over and over in identical cycles. The James Webb Space Telescope is honestly the most powerful time machine ever built, capturing the faint infrared light from the most distant and therefore the earliest galaxies in the universe. Some of the initial findings from JWST have been really surprising, finding galaxies that seem to be way more massive and well-formed at an earlier cosmic epoch than models predicted. We stand at a truly remarkable moment in the human story. The question of our cosmic origin was really the domain of priests and philosophers, but today it's a question we can actually investigate. Did it all begin in a flash of light 13.8 billion years ago, or have these stars played out their lives in countless universes before ours? We don't know yet, but we are looking. And for a species as curious as ours, the search for that unwritten beginning is a destiny we gladly embrace.